بسم الله الرحمن الرحيم رب زدني علما.
Now in this video we'll be getting into some of the layer 2 kind of connections by using sub interfaces. Now probably in this section I'm going to use all the trunk links. All the links are trunk links here. Like in the previous sections, whatever the logical interfaces we have seen different combinations. Like in some connections we have used some SVI interfaces on the switches, and in some connections we have used some sub interfaces, and in some connections we have been using layer 3 interfaces. It all depends. But in this lab I'm going to show you how we can build a logical multiple connections between the routers by using only one interface. Like let's take an example. I got a router 1. Now I want router 1 to have a direct connection from router 2, and also to have a connection to router 3, also to router 4, also to router 5. Now in this way you need to have, normally if you want to have some direct connection from router 1 to all the routers, in that case if I go with a normal connection, I need to have some separate connection to router 2, and then to router 3, and then to router 4, and then to router 5. So which means I need to have 5 different physical interfaces which is required for me to build the connection. But that can be possible by using one physical interface. Now what I can do is I can configure the opposite interface as a trunk, and on this router, as I'm using only one physical interface, I can build 4 separate, in fact 1 to 2, I can build 4 separate sub interfaces, 1 to 3, 1 to 4, and 1 to 5. And all this, each and every sub interface goes virtually to every router. Now that is possible, and this is something really useful for you to build normal layer 2 connections if you are setting up your lab, or this is also useful in the service provider networks. That's how they provide a connection to multiple customers on the same interface. We can still have multiple WAN connections on the same interface by using sub interfaces kind of implementations. Even if probably it can also be useful in the CCI lab exams, where you may have some kind of topologies where you'll be building some logical topologies based on this kind of scenarios. So we'll see how it is possible and what are the specific configurations we need to do. Now the basic prerequisite knowledge you need to have the concept of VLANs and trunking, just like the same thing what we have discussed in the previous layer 2 topologies again. And also you need to know how to create sub interfaces on the router. Apart from that, everything is going to be the same. So just to understand, I'm going to build some logical topologies here, where I'm going to assume that there is a connection from router 1 to router 4. If I want, I can build one more connection from here to here as well, because it's going to be logical again. Anyway, I'm not going to do that. If you want, you can just for practice purpose, you can build one more logical connection from here to here as well as here to here as well. So we can build a full mesh, a logical topology between each and every router without adding any extra links, by just adding some few configurations. It's going to simplify a lot of things here, like you don't need to have separate interfaces. Now it's going to you can follow one standard physical topology, and you can build multiple logical topologies inside that without even changing the wire. So that's one of the major benefit you get. Now this is a little bit useful again if you are building your own CCI rack. Also we can build some logical topologies based on this. So let's go one by one. I have a pre-configured topology here, exactly the same way I have connected as of now. Now I'm going to build some logical topology based on this diagram. Okay, I want a connection from router 1 to router 2 and router 1 to router 4 as well. As of now, I don't need from 1 to 3. If you want, we can build. That is something you can do on your own. So I'll go to router 1 first. I'll start one by one, starting from router 1. Now the first thing what I'm going to do is, anyway on all the interfaces I'm going to use them as opposite side. I'm using sub interfaces. So what we do is we configure all these interfaces as a trunk links, and these trunk links will carry all the VLAN traffic by default. And if you are very well aware on what specific VLANs it is going to carry, you can specifically mention those VLANs. You can do some kind of pruning. That is something you can do. But I'm not going to getting into that here as of now. So let's go and configure all the links as a trunk links here. 5 links on the switch. I'm connecting F0 by 1 to 5. Switch port, trunk encapsulation, switch port mode trunk, and then no shutdown command. Anyway, the interfaces are up here. Now if I verify show interface trunk, I don't see any trunks because right now the interfaces on the routers, they all are in shutdown state. Okay, so let's go one by one. Let's build some connections on the router 1. So the first thing, I'll go to router 1, and on the router 1 I'm going to create 2 sub interfaces. So I have only one connection. I'll say no shutdown, and then I'm going to build 2 connections, that is F0 by 1.12, and I'm going to assume that it's a VLAN 12. We need to create those VLANs as well on the switches, and then I'm going to assign the IP address as 10.0.12.1 255 255 2550. This is on the router 1, and the same thing, I'm going to create one more sub interface, that is going from router 1 to router 4.14 encapsulation.1q14, and then I'm going to give the IP address as 10.0.14.1. Done. Now show IP interface brief. So we are going to create these 2 sub interfaces here, and they are carrying the VLAN 12 and VLAN 14 traffic. So let's now one more thing, we need to ensure that on the switch side there should be a trunk link, which we already did, and the next thing is the VLAN must be created on the switch. Now you need to be very careful, especially in your CCI exams, when you have a logical topology built. If you are running some VTP kind of implementations, if the VTP is not synchronizing between the switches, there is no VLAN created, in that case you may see some connectivity issues. So just ensure that the VLAN is created, whatever the VLAN you are using. So let me create all the VLANs once here. So I'm using VLAN 12, VLAN 14, VLAN 34, and then VLAN 35, that is 3 to 5, and then VLAN 25, which is going from 2 to 5. Total there are 5 VLANs. You can see 1, 2, 3, 4, 5. I got 5 connections, so 5 VLANs created. So let's do the same thing on the router 2 as well. So I'll start like this. I'll go from router 1 to 2, 2 to 5, like that. So clockwise. Let's go to router 2, and on the router 2 again I'm going to create some sub interfaces, making the physical interface up, and then I'm going to create some sub interface with 12 encapsulation, and an IP address 10.0.12.2 255.255.250. Now I should be able to ping between 2 to 1 because I already finished the configuration on the router 1. It takes some time because on the switches the spanning tree has to converge. So I should be able to ping, so which is going to confirm that the connectivity between router 2 to router 1 is okay. So that's how we are going to verify. We'll start up with the configuration on the router 1, and then we'll do it on the router 2. At the same time, we'll go and verify the connectivity between 1 and 2 because 1 and 2 is already configured. Now the same way we are going to do on the 2 to 5 as well. So on the router 2, I'm going to create one more sub interface which goes from 2 to 5. So I'm using the numbers as per the router numbers, and the VLAN numbers also as per the router numbers. Now you have to go with the numbers whatever is given for you in the examinations. So encapsulation.1q25, and then IP address, it's going to be 25.2, and then the next thing done. So we just have only two sub interfaces created on the router 2. If you want, we can add some more as per our logical requirements. Now let's go to router 3, not router 3, the next router is router 5. So I'll go to router 5. So on the router 5, this is my router 5, interface F0 by 0, physical interface is up. And then first I'm going to create a sub interface connecting between 2 to 5, encapsulation.1q25, and then the IP address 10.0.25.5, and then the /24 subnet mask. Now hopefully if everything is okay, I should be able to ping between 5 to 2, 10.0.25.2. I should see the communication. Meantime I'll quickly configure the other interface as well. What's the other sub interface? 3 to 5, 35, encapsulation.1q35, and then the IP address is 10.0.35.5. So I should be able to ping between 5 and 2. I should see the reply. You can see it's coming up. Let's go to next router, router 3, and verify the same. So on the router 3, so this is router 3, interface F0 by 0, physical interface has to be up, and then interface F0 by 0 dot 35. So I'll start with 35, encapsulation dot 1Q 35, and then IP address 10.0.35.3. So I'm using 3 on the router 3, and then interface F0 by 0 dot, what is the other interface? 34 dot interface, encapsulation dot 1Q 34, and then the IP address has to be 10.0.34.3. Done. So if I verify the interfaces, I can see the interfaces are up. And the next thing is I should be able to ping between the router 3 to 5, because I have already finished the configuration between 3 to 5 on both the sides. You can see the replies coming. Now the last thing, I just need to fix only between 4 and 3. So let's go to router 4. Router 4 command line. So on the router 4, hostname is router 4, interface F0 by 0, no shutdown command. And then I'm going to create some sub interface on the router 4. I need to create a sub interface between 3 to 4, encapsulation dot 1Q 34, and then IP address is 10.0.34.4 255.255.255.0. And then the other sub interface I'm using is 14, and then encapsulation dot 1Q 14, and then IP address has to be 10.0.14.4. Done. So now finally I should be able to ping between all the interfaces, because I'm done with the configuration on all the sites. So I'll start up with 3 first. I should get the reply, and also I should be able to ping between 4 and 1 as well. Now I can see this is how normal layer 2 connections are built by setting up a one physical LAN connection. Now I did not modify anything here. It's just a normal physical topology, but based on this normal physical topology, I can build virtually many logical connections. You can see I can have one more WAN connection from here to here if you want, 1 to 5, and I can also build one more WAN connection from here to here. Like that, I just have only 5 devices here. Even if you have 15-20 devices, you can build any number of logical connections by just configuring the opposite side of the switch ports as a trunk ports. And on the routers we can create some interfaces. Now when you do this configuration, there are a few things we need to keep in mind, especially in the troubleshooting sections, where you need to ensure that whatever the VLAN you are creating on the sub interface, that VLAN should be correct on the router side, and the physical interface has to be in no shutdown state, and that you can verify with no show IP interface brief commands. Now these are and the IP address also should be correct again, with the correct IP address and the correct subnet mask. Let's say there is a problem between router 1 to router 3. Now the next thing we need to see whether the opposite interfaces has to be configured as a trunk, and those trunk link must allow the VLAN 13, because it is 1 to 3 on both the sides. If that particular trunk link is not allowing the VLAN 13, in that case you won't see the communication happens. And especially if you are using some VTP, because VTP kind of things, VTP pruning kind of things, there might be some cases where you may have modified the VTP pruning list where you have removed 13. So the cases can be anything. You need to ensure that that particular trunk link must carry the VLAN traffic, and they should be configured as a trunk links. And based on this, we can build as many logical connections between the routers we want.